Welcome to the C++ Club. This is meeting 173. Right, first of all, I wanted to mention one of us we lost. It's Rainer Grimm, sadly passed away in October last year. I didn't know him personally, but he seemed to have been a great guy and an excellent C++ educator, and it's a sad loss.
I've met him a couple of times at different conferences, and you're absolutely right in your assessment. It's so unfortunate. Maybe I may give you the information that his son is trying to keep on with this blog here. And I might appear there sometime in the future.
That's good to hear. That's good news. Thank you. Hopefully his life work continues this way. Next item is a bit of a feedback reaction. Last time, which was a very long time ago, I mistakenly said that CMake was a product of a company called KDAB. Obviously, that was wrong. I'm correcting my record. It's of course Kitware. And we'll talk about CMake later. Other news, I have a blog now. Yay. It's pretty much empty, except for one record. Sort of an explanation why it took me so long to restart the meetings. I've been on a very intense project since the last meeting. The project lasted for about a year and a half. It was a really, really interesting project. And now that it's over, I wanted to mention what I was doing there. I was brought in to implement a particular piece of infrastructure, expose an internal system to clients using a web service. And while I was doing that, naturally, I tried to optimize the build system, as one does, made it quicker than before. That particular code base built in 7 minutes before I started with it. And after that, it was less than half a minute. Obviously, I cheated a little bit with Ccache, anything to make the build quicker. And then I was extended to do the same build improvements in another code base.
Did you use any particular tools to analyze the build times?
Later on, I introduced Clang Build Analyzer, and that helped pinpoint parts of the code that the other developers then looked at. But my main objective, apart from the actual main one, was I wanted to introduce static checking, because they only had pretty much a single build using CMake, and that was either release or debug, depending on what configuration command you ran last. Everything built into the same build directory, which was inconvenient. And also in the other code base, they did something I never encountered before, which was they built their test binaries into the source tree. And that was not ideal.
That doesn't sound right.
Yeah, it was not ideal. My goal was, first of all, to enable different build types in such a way that each of them built into its own build directory, build tree. My idea was that if I had that, I could then set up a continuous build in such a way that all those builds could be done in parallel, because they would not be interfering with each other. But in the second code base, that wouldn't be possible, because the test binaries would override each other. There would be race conditions in the file system, which I didn't want. So
I can see why you experimented with Bazel. Did you have to then go back to CMake, I see here?
They only used CMake. As often happens with CMake, you just Google a working configuration, then you cut and paste lots of stuff, and you then don't touch it because it works, or you think it works.
You hope not to touch it.
Or you hope it works. And slowly, over time, it grows various appendages and strange build commands that you have to run. So unpicking that took quite a long time. But in the end, I had builds that used CMake profiles, which frankly saved me. It was such a great life quality improvement for anyone who works with CMake. I came up with a scheme where the profile name expressed the build flavor, so to speak. For example, I had a build called GCC _ debug, deb, and GCC rel, and then I also introduced a Clang compiler. The production was GCC, but I could run Clang build in parallel, and that enabled me to also use all the Clang tools, including Clang Tidy, all the Clang sanitizers, alongside GCC sanitizers. I was lucky that they stayed on pretty much the latest compilers, so I think by the end of it, we used GCC 14 and Clang 19. Well, not the cutting edge, but still pretty new.
Better than the average of the industry.
Yeah, definitely better than many. So yeah, by the end of that exercise, I had those builds running in parallel. Those included debug release, all the sanitizers, not all the sanitizers, address, undefined behavior, and thread, setting up memory sanitizers and exercise and frustration. So I didn't do that.
Did you have Valgrind on the side?
Another build was released with debug information for Valgrind. Everything was running on Jenkins. And yeah, the entire build set took about an hour.
That's pretty good.
Yeah, and I scheduled it once a day at night, so that it didn't interfere with any other builds. The first code base was 1.5 years old. The other one was more than 10 or even maybe 15 years old. C++23 was enabled in both. And it's not like everyone suddenly started using those C++23 features, but if anyone wanted to, they were there, like string contains, oh my God. Imagine that. Most new features were in use, especially concepts. That was nice. That was my first time dealing with using concepts, and I really, really liked it. There was quite a lot of template code. I decided after some Googling to use a Drogon framework for creating a web service. That was really nice, and I combined it with some templated code to make it easy to add new endpoints. It was really quick and easy to set up. And the benchmarks show that Drogon is one of the fastest available C++ web frameworks. So yeah, if you need...
I didn't know about this Drogon. Is it like a header-only perhaps thing, or is it something Let's
see, I don't think it's header-only. I think I had to build it and set up it as a library dependency.
That's actually good. If you want to increase build times, use header-only libraries.
In fact, I wanted to ask you, what was the biggest bang for your buck when you wanted to reduce the time for compilation? Did you find that too many includes, or perhaps too many templates were the problems, or a combination?
Circular dependencies were the biggest culprit for long build times. I found an interesting thing about Ccache. Apparently, the new version of Ccache, starting from version 4, supports a remote cache in the same format as Bazel. So if you have a Bazel cache server running somewhere, you can use it alongside Bazel for any Ccache remote storage. There is an option that you can set up, and it works out of the box. The whole thing was a lot of yak shaving. So in order to do one part, I had to set up a Bazel build of a framework called TensorFlow. It's like a machine learning thing. I think it's by Google, and obviously it uses Bazel. And they didn't have Bazel, so I had to onboard it. And then I discovered that the full build of TensorFlow took 4 hours. So after that, I had to set up a remote cache, which was fairly easy because they used Docker infrastructure. And I just found a Docker image with a ready-made Bazel cache server. Then we pointed it to Amazon AWS. And by the time I left, there was plenty of space left in that cache. And then after that, I discovered that Ccache supported it as well. So the interesting result of it was that often local cache in Ccache was slower than using the remote one. I suspect that might have been because the local storage was getting full and was just thrashing, trying to clean up, and then that potentially slowed it down. I have to mention that both projects were in teams that were working close together, and both teams were excellent. They were really easy to work with. Fantastic experience working with them. So the last thing that I did was I tried setting up modules, because by the time my project was, my consulting gig was up, I had a couple of weeks left and everything was pretty much done. So they said, why don't I look at using modules? And sadly, GCC 13 had a few bugs and just didn't work. So I left it all more or less prepared for them for when they migrate to GCC 14. And then it all should work, at least with a single project. The goal was just to convert a single part of the project to modules and see how it goes. So Clang 19 worked perfectly.
Did they have a specific goal to try and get modules working? Was it working in other stuff, or was this just wanting to experiment with something that probably should work by now?
It was the latter. They wanted the latest feature. They knew all the advantages of having modules, and I'm guessing the most sought after feature of modules was code isolation and organization, not the build time speed up. The main thing was to use modules to make it all tidier and more isolated and prevent further circular dependency from appearing.
Good approach.
Yeah, and they were just they just wanted to prepare for the future. I was glad to see that they stayed on the latest compilers, and their internal systems were easy to work with, and upgrading infrastructure related stuff was pretty easy. So yeah, CMake is a terrible mess, like I like to say, and everything I learned about it was against my will. My advice is to use CMake presets. They are supported by VS Code out of the box, and if you make CMake presets sort of the first-rate citizen of your build, the source of truth, that gives you the ability to repeat builds both from the terminal and from VS Code. The build artifacts go in the same directories, so you don't end up rebuilding stuff as you switch from terminal to VS Code and back. That was my first time working with Docker and dev images, and I really liked it. When I was being onboarded, after an hour, I could build the entire code base with all the debugging and stuff. So for me, as a consultant who goes from firm to firm, that was like a thing unheard of. It usually takes days, if not weeks, to get onboarded properly and start building and committing. And here I am in my first day opening a PR. Pretty good.
I worked in finance for a bit once, and my first contracting role, it took weeks to be able to commit any code, but it was the same problem. All the other people went, hey, it builds on my machine, but there were circular dependencies going on, and they just walked themselves to a point where they'd got an old DLL that it kind of bootstrapped itself. And it's when we started trying to set up CI, it became apparent what was happening, and we managed to fix it as well and get it down to you be able to build something within an hour. Circular dependencies again, honestly.
when I came on the project, their initial structure was in the source tree, you had multiple projects. Every one of them had their own CMake lists. There was the main one in the root of the source tree. And the thing that was the culprit was they added the source tree root directory as the include to all the projects. And so every project was free to include anything from anywhere. And obviously that wasn't ideal. It resulted in lots of circular dependencies. As for the IDE, they preferred VS Code. I initially dismissed it because it's a browser. I mean, JavaScript-based IDE for C++, come on. But it turned out it was pretty good, especially because it supported dev containers much better than, say, CLion. Till I left, I couldn't get CLion working with dev containers, no matter what I tried. It was always broken in different, curious ways every time I tried it. So I stayed with VS Code.
I think most of the people I speak to, they have similar opinions. We all came to VS Code with suspicion, thinking that cannot be for me. But then there is the divide. Some people are the hardliner. They will stick to Vim and Emacs. More power to them. Otherwise, for common mortals like myself, I think VS Code comes with batteries included. Everything works out of the box. It's fast enough. Certainly, it's not slowing me down. My own brain is the bottleneck here, not VS Code. So it's good enough for me.
Yeah. So this was the first time I used Mold Linker. If you haven't used it, I strongly advise you to try it out. It's a drop-in replacement for the Gold Linker and LLD, and it's so much faster than anything else, even faster than LLD. It's really good. The guy who created it was the same guy who worked on LLD. Ccache with remote backend and distcc also helped. We only had one distcc server, but it was a pretty powerful one. So Clang build analyzer, although getting useful results with Clang build analyzer is more difficult than tweaking the build because it usually requires quite a bit of refactoring and getting rid of unnecessary templates and stuff like that. So it's more of a strategic engine that can advise you what to look at. One other feedback was that the release process must require as few manual steps as possible. And I made it my goal to set it up in such a way that build would only require at most 2 commands. One to configure, including running the configuration stage of CMake, and the other one to build. Clang format, I set up Clang format. Yeah, Kubernetes is great if you are a YAML developer.
Were you using Kubernetes just for your build flow, or was it actually being used for deployments?
It's deployments, yep.
So all the prod applications were running through. They were all containerized.
Yep.
Interesting. I hadn't talked to anybody in the space that was actually using it, because the tests that they had all done, even though the performance was negligible, but it was measurable, and they didn't want to pay the cost for it. So was that an issue at all, or has that been solved?
I don't think performance was a huge bottleneck in that particular setup. Most of the clients used Python, so it wasn't like C++ based code running in a container would slow them down. In those cases where there was a slowdown, it wasn't because of the container, but because of the problems with C++ implementation, for example. But the deployment was a breeze. It was very easy. When I came on a project, I was like, so do you have a team that does your deployments? And they smiled and said, nope, we just do it ourselves. Just edit one YAML file and it's done.
I'm surprised they didn't look at you and said, now we do.
They did prod deployments several times a day, all by themselves. If anything went wrong, they just reverted to a previous good version, and fantastic. I really liked it. Right. Let's go to the next item. A brief history of Bjarne Stroustrup. Bjarne Stroustrup. He explains how to pronounce his name in this video. It's a short video. I liked it. It's a good production value, very light-hearted.
It was funny.
Yeah, it was pretty funny.
I found it very humorous. It was nice.
And they're going to produce another one about C++, I think.
Feature-length one or another small one again?
I don't know. It's like the next step, probably, in the history of Bjarne. I bet that one will be fun. Right, Gianluca.
Oof.
This is you.
I have to change that picture, though. So, thank you for warning me that we were going to talk about this. I remember writing this last summer, and I was pleased that somebody else posted it. I thought it was going to get just ignored, and I got a few upvotes on the sites. I mean, got a couple of very good tips, which I implemented. And overall, I was pleasantly surprised. So I think, I dipped my toe in the reflection feature, and I couldn't get enough of it. Certainly, I would suggest anybody to play with it.
Sorry, for the podcast listeners, can you say what the title was?
All right. So I implemented a little reflection-based program that would produce a UML diagram at compile time with some cheating, and obviously it's not supposed to be a real implementation of anything. It's just a bit of a toy program that would navigate the tree of your classes and output something that is plant UML script that you can just then plop into a viewer and produce a diagram of sorts. So it's an experiment, but it taught me a couple of concepts, and I had fun writing it. So definitely suggest everybody to play, if they can, with reflections. Unfortunately, we at work won't be able to for a while, because we are far from the latest compilers. But if anybody can, and maybe people in other industry can, then go ahead, please. It's I don't know if you're going to also talk about some talks that did a very good job at explaining reflections much better than I could in my post. Like there was a Barry Resvin talk in CVPCon last October. That's great, but there's a bunch of them. There's Herb Sutter's talk.
It'll be one of the next times, not this time. Gianluca's article is titled C++26 Reflections, Adventures, and Compile Time UML. And there is a page that you link in Compiler Explorer, which shows the execution and the result of it. And it's really amazing.
It was amazing how easy it was, and how much I can now get away without learning proper metaprogramming.
You said your experiment had a bit of cheating. I would say reflection is sort of cheating.
Well,
when the program reflects
you
itself.
get the keys to the kingdom. Yes,
yeah, exactly. It's like a meta world.
Has anybody seen the latest a blog by Ben Dean?
Oh, no.
Where he was speaking about reflection and the limited ways of code generation that is coming along with it in C++26 is actually capable of doing type calculations in the reflected world. So, yay, no more template metaprogramming to calculate types.
This is amazing.
Does this mean computing like unique types, or does this mean like being able to generate, for example, a strong type for an alias?
It was more general. It was about the fact that you can use only template metaprogramming if you want to compute something along with types. We have value-based metaprogramming. This is a pretty old kind of thing with const for now. But with type calculations, we couldn't do that with the facilities in C++ up and until 23. But with 26 and reflection, we can actually do also type calculations in the meta world without using templates for that. Because, templates require memorization and specializations, and this is really expensive to the compiler. So now we have everything we need to actually write complete programs within the space of a compiler.
That's interesting. Can you at the same time, can you also tell whether the class has been defined or whether it's incomplete or not?
I didn't really understand what you were trying to ask. What do you want to repeat?
Currently, you can't tell in the language if a class is defined or not, right? If a type is actually defined or not, or if it's just aliased. And because there's a lot of template things that require the class to be defined for it to have defined behavior, but you can't tell currently at compile time. And I was just wondering if maybe you could do that with reflection.
So you mean you speak about if you can sniff out at compile time if a particular specialization has happened before?
Well, no. So let's say you just have struct foo semicolon. You've declared it, but you haven't defined it.
Okay.
That's what I want to be able to know. If I'm looking at a type, has it actually been defined or has it just been declared?
I would try the eyebrow operator to actually bring this particular expected type into the metaspace and see if it fails. I don't know if it's possible, but I haven't had any chance to actually play with reflection so far. But Gianluca will probably jump into that.
I don't actually know myself. Of course, again, I think there's so many things I don't know that I feel so ignorant just looking at the many things that one could do if we just manage to master this feature in general. I've seen about this just recently in the practical, I think the talk was called Practical Reflection or Practical User Reflections by Barry Resvin. And he would just declare the class and then open a const-eval scope to define it with some metaprogramming logic. Obviously that doesn't answer Jody's question, but
for that specific one, if you've got just a declaration, when you then in the reflection, if you've got the option, you can iterate over the contents. In that case, if you tried iterating, it would be empty. So you could have a bit of logic there to say if there's nothing to iterate, or if the iteration is null, then it is.
So it won't fail. It'll just not. It won't have any elements.
Exactly.
But it wouldn't distinguish between an empty class and a.
No, I'm not sure. I'd have to dig to find out if there's a specific way to then dig further. But that was one way that if you try to iterate, it would be empty. But interesting. I'll dig into that and find out.
So Gianluca, with this example that you were talking about that Barry had, does that mean that at compile time with reflection, I could define a type and then I could iterate over another type? Like I could say, define a type name. And basically, I just wanted to act just like a string, except I wanted to be, in other words, a native strong type. And then I could just iterate over the string and pull everything from a string into that guy's space. And now I've got a new strong type that acts just like a string.
Yes. So you have and do look at the full implementation, the full example in the video that he presents. It's honestly mind blowing. Is building these classes on the go by just declaring the type. In this case, it's declaring a little bit of a vector class, and then it just goes declaration, then const-eval scope, and adds on top that whatever it wants, and after the scope is done, the type is defined. And in the scope there, it did marvelous things, all sorts of backwards flips that blew my mind, honestly.
Do you know which talk this was?
Yeah, it was practical. Let me just look it up. Practical Reflection with C++ 26, Barry Resvin, CPPCon 2025.
And Jody, to your question regarding the existence of a particular type, I think you should be able to do that in C++ 20 with requires expressions.
Yeah, no, Yeah, and I don't think you can. I've been down this road with some other folks before, but I would love to see that. There's the problem is that if you do it, is that the memoization, once you've decided whether it's defined or not, that will change once it becomes, like, if you say, oh, it's not defined, and then later if you ask, and it has to change to be defined. And so there's a chicken and egg problem there, and actually determining at which location, because of the memoization.
I didn't speak about this memoization kind of thing because you were asking about a non-templated class. And in the case of a non-templated class, it should be possible to do it with a requires expression. You ask for the existence of a type, and it should just fail to give a valid expression in there. And now you should be able to actually say that the attempt to do that requires will be evaluated to false.
We can do some experiments probably and see that.
Yeah, that's what I'll be doing when we hang up.
Thanks. Oh, Bjarne. Hi, Bjarne. Thanks for joining.
Hi, I thought I'd just pop in and say hi. I'm in meetings until now and from 10 minutes from now, so it's just to say hello.
Thank you. We were just discussing a video about yourself. This one.
That seems to be popular.
Yeah, the general consensus is that it's a pretty nice video. It's quite funny and good production value. So looking forward to the next one.
There'll be one on C++ in May.
It's really nice. And you did explain how to pronounce your name, so that's good.
Yeah, I mean, 20,000 views a day on average for the first couple of weeks. It's pretty amazing.
Yeah, they did a good job, I thought.
Yeah.
One thing that Fran mentioned was this about cppreference, that there was a case of a vandalism. It was some time ago, but since then it's been put in read-only mode, and so there's no new C++26 content there.
They're working on it.
It's been like that for over a year now. There's a little banner up saying they're working on it, and there was an email that you could send support to, so I did, but it's been the same state for over a year now, which is unnerving, I think.
Yeah, it's really sad. Everything has been superseded by Rust, according to this troll person who did it, who vandalized it. Okay, it was pretty childish, but the result is still that we don't have a reference at the moment.
But we have alternatives.
We do. There's now CPP docs.
For example.
Yeah, but they say it's based on the content from cppreference. So presumably there won't be anything new, although they do have a C++26 filter. I don't think the filtering works at the moment. I couldn't get it working.
I just sent a message asking.
Right. Yeah, hopefully it'll be revived at some point, or maybe this one grows. It'd be good to have a point of reference somewhere.
Well, otherwise you'll have to read the textbooks, which are, well, on paper mostly, and not organized for lookup, or the standard, which is unreadable for ordinary mortals like me.
I bet someone is going to try and ask ChatGPT to summarize C++ standard, and we'll end up with a couple of pages of gibberish. So that's good.
Either that, or it'll burn down a couple of extended.
Couple of burnt lakes later, we'll have a couple of pages that are useless. Yay. Yes. So I promised to talk about CMake. If you're not still too bored of it, it seems to be everywhere. And this one is a bit outdated.
I would like to listen to this, but I can't. I have to bail out again. I promised just to come and say hi.
Thank you very much for joining, if only briefly. I'm sure I wasn't the only one who hoped that CMake 4 would be a major improvement, to the point that someone on Reddit said, it's new major release because they completely overhauled the language to be more readable, right? Right? What are even version numbers? They seem to be using them very arbitrarily. It's like CMake 3.28 adds support for C++ modules. CMake 4.0, minor improvements. I mean, of all the build systems ever created, CMake is certainly one of them.
You know that CMake still hasn't any support for header units, which means half of the modules feature.
And it's not like all other build systems are perfect. It's like the other build systems that do support modules that come to mind are Meson? I'm not even sure about it. There was a...
Meson is a big critic of modules.
Oh yeah, I read his blog post. He seems to be very against it, and he seems to only focus his attention on the build time improvements of modules. I think it was some other person's contribution to the Meson code base to introduced some basic support for modules, and that's pretty much it. Except
we have multiple alternatives. CMake is the biggest one.
CMake. Yes, I'm very fond of CMake because in my personal toy projects, it removes all the friction that usually is associated with a build system, and it just works. I hadn't tried its module support yet, but from what I read in the documentation, it's been there for several years now, and it's only getting better. So
I'm using MS Build, and MS Build is working like a charm for many years now. Unfortunately, you can't use it.
Like I was going to mention on the feedback of my last project, that life is pretty good if you don't have to build for Windows.
We only build for Windows. We have no troubles.
I think the trouble starts happening when you're trying to build for more than one platform. So it depends where you're coming from. But it's not insurmountable, but yeah, it adds challenges.
There was a talk by, I think, Bill Hoffman, who is one of the main people, or maybe even the person behind CMake. And the talk was 25 years of C++ build portability. And the comments are brutal. The first one, I don't understand how it accepts CMake. The fact that Bill Hoffman tends to apologize for CMake design in all his presentations makes me feel bad for him. But at this stage, what can you do? I mean, one of the ways forward that I can see would be to treat CMake as sort of an assembly language for the build and use CMake file generators like CMake to produce CMake files and then build with CMake, introducing one more layer of indirection, which, as we all know, is a solution to everything.
Yeah, I mean, that's effectively what I used to do it's a long time ago when we were doing KDE developments. And it was, you effectively use the Qt profiles, the PRO files, and they would then generate the CMake file for you. And, I was quite happy using CMake. It just worked, but you never actually touched it yourself. You work at a level above defining the Qt files, and then that spits out CMake.
This is the way.
Yeah.
I think we're out of time. I wanted to show you this post on Mastodon where someone said, C/C++, hey, compilers are a tool to convert source code into undefined behavior. And there was another one, I'm a full stack developer in that my stack is full. And if you try to push any more tasks on me, I'm going to overflow it and start corrupting my own memory. Right, I think that's it for today. Thank you very much for joining, and I'll see you next time, hopefully soon. Bye. Bye.
Cheers.